Greetings and welcome, friends. Mr. Waddy and my in real life friends, algebra buddies here. We were talking about graphing y equals, or I'll tell you what, f of x equals a parentheses x minus h all squared plus k. All right, so this is vertex form of a parabola in which a determines, right, our slopes, whether we're opening up or down, and then h and k determined the vertex h comma k. The tricky thing about the h is that it's the opposite of that number. So now what we like to do as mathematicians, once we've developed a form or a model, we can then apply it to real-world situations. And we've talked about some of the applications of parabolas already. But here we go. Here's example 5. It says water fountains are usually designed to give a specific visual effect. For example, the water fountain shown below consists of the streams of water that are shaped like parabolas, because thrown objects behave like parabolas and water molecules behave like parabolas when they're thrown through the air on planet Earth, as well as other planets, as long as they have some form of gravity. Notice how the streams are designed to land on the underwater spotlights. I don't have the pictures here, I'm sorry. But here it says, okay, write and graph a quadratic function that models the path of the stream of water with a maximum height of 5, represented by a vertex of 3, 5, landing on a spotlight 6 feet away from the water jet, represented by 6, 0. So let's graph this first. So 3 over 3 and up 5, this is our vertex. So this is our h and k. Right, so I know that h and k. It will be in our equation, but they gave us the vertex, so I'm just plotting it as they gave it. And then they said that it's going to land at 6, 0. So this point will be on there. So 6, 0 is just a particular x-y combination that will land on our parabola. I understand it's going to be a parabolic path. This is going to be the vertex. Oh, actually, tell you what, since this is the vertex, I know that there would be an axis of symmetry that passes through this. And since this is 1, 2, 3 units away over to here, then that means 1, 2, and 3 units away over here is going to be another point. So the origin also happens to be on this. So what I'm going to do, we used to do problems like this with slope-intercept form as well. I don't yet know the a. Now, I expect that this parabola probably opens upside down like this, right? Probably something like that. But I don't know the a value, so I'm expecting the a is probably negative. But what we're going to do is plug in what we know and solve for what we don't. So I know 3, 5 are the values of h and k. I know that 6 and 0 would work as an xy combination. So let's plug those in and solve for a. So 0 is going to equal a. I don't yet know what that is. X is equal to 6. H is equal to 3. Right, there's my h and k. So minus 3 all squared plus k is 5. So if I plug in what I know, I can now solve for the a, right? Just like we used to plug in things to solve for the slope or the y-intercept in slope-intercept form, I'm just plugging in everything. And now I've got to get a by itself. But before I do that, let's simplify this. What is 6 minus 3, folks? 3. And let's see, what is 3 squared? 9. So I'm going to write this as 9 times a plus 5 equals 0. And now, how could I get a by itself? It's being multiplied by 9 and added by 5. I like it. I like it. Equals 9a. And now what? Yeah, divide both sides by 9. And I can solve for a. I can see that a is going to equal negative 5 ninths. All right, so even though that's weird, I just found the equation using a and hk. I could now write the equation of this parabola as being y equals negative 5 ninths parentheses x minus 3 all squared plus 5. And so with a little bit of information, I was able to now write an equation for this parabola. And I could then even in the future make predictions using this equation. I could say, right after, if the x-axis was time or something like that, or I guess maybe this is horizontal position, x and y, I could say when the water is 2 feet away from the fountain, if it starts over here and it's shooting the water this way, let's say, I could say how high is the water when it's 2 feet away from the fountain? And you could say, oh, it's going to be, right, whatever 4.5 is, looks like. And I could actually evaluate the exact value there. And then I could have all sorts of cool hoops that the water jumps through. And I'd know exactly where to place those hoops. And people would be like, ooh, your water can go through hoops. And I'd be like, it's all about the parabolas. And they'd be super impressed, right? They'd be amazed at my hoop jumping parabola skills. And I could predict everything using my new equation. All right, so, well, if I project water from that fountain, I could predict where it would be in the future, assuming it is uninterrupted by other forces or people. So let's do the same sort of problem with monitoring progress question 9. But this is the idea, right? Label everything, plug in what you know, and solve for what you don't. Okay, that's the idea. That's the idea. Okay, so it says, okay, what if the vertex is 3, 6? So here's going to be my HK. So this is going to be a steeper parabola. So 3, 6. All right, so 3, 6 is my vertex. Because, right, I could maybe change the positioning on the fountain so it shoots the water up higher now. And let's say it still lands on like whatever spotlight is here at 6, 0. So this is going to be an x and y combination on my parabola. This is going to be my h and k, and I'm going to plug in what I know and solve for what I don't. So y equals a parentheses x minus h all squared plus k is my vertex form. And let's plug it in. So 0 equals, I don't know a yet, x I'm saying is 6, minus h is 3, all squared, plus k is 6. So let's have you guys solve that for a using algebra. I'll walk around and help you out. All right, so here we go. Mr. Waddy's back. I'm going to have 0 equals a times 6 minus 3 is 3 squared plus 6. 3 squared is 9, so I'm going to write that as 9 times a. Similar to the last problem, very. This time, I'm going to just subtract 6 from both sides. So I'll have negative 6 equals 9a, and then divide both sides by 9. And 6 and 9 are both divisible by 3. So 3 goes into 6 twice and into 9 3 times. So I'm going to get a is equal to negative 2/3. So there's A. Actually, I'll write it in green so we can be cool. A equals negative 2/3. And therefore, my equation will be y equals negative 2/3, parentheses, x minus h, hold up, Bren, minus 3 all squared, and then plus k, which is 6. So plus 6. And let's actually verify this in Desmos. Desmos calculador. Oh, there we go. So we had the point, what, 3, 6 was our vertex. Look at, oh, there it is. Don't pack up, Brandon. Yeah, you don't need to put stuff away just yet. 6, 0. 6, no, 6, 0. There we go. So there we go. And let's write our equation. So what did I just say my equation was? Y equals negative 2/3, parentheses, x minus 3 squared. And looks like my parabola needs to be shifted up 6. Bam. And look at my parabola, in fact, hits both of those points. Let's actually even, I'll change the color of this parabola to blue so it's so cool. Look at that. It's like the water is amazing. All right, and let's actually graph the other one as well. Y equals, what was that, negative 5/9? Negative 5/9 x, oh, I gotta get out of that denominator there. X minus 3 all squared plus 5. And so check that out. I've got two parabolas that actually start at the same place and end at the same place, but they had different vertices, which vertices is how you pluralize the word vertex. So this one passes through, what was this, 3, 5. There you go. So, so you can see that. So you could actually have, as a result, multiple streams of water on your fountain shooting at different angles and then having different arcs and still landing at the same spot. Yeah. They'd be starting at different places. So, so thanks for watching, internet friends. Have a great day.